Right now, at this very moment, the ocean off the coast of Naples is doing something it shouldn't be doing. Bubbles. Violent, frantic bubbles breaking through the surface like the sea itself is boiling. And here's what makes this terrifying. Scientists just confirmed these aren't random. They're appearing in the exact same spots where the water started bubbling right before one of history's most catastrophic volcanic eruptions. And what they're finding beneath the waves is forcing them to ask a question nobody wants to answer. Is Naples about to witness the birth of a new volcano? At first, nobody took it seriously. A few fishermen noticed patches of bubbles rising through the calm waters of the Bay of Naples. Strange, sure, but nothing to panic about. Except the bubbles didn't stop. They kept coming back, day after day, forming tight clusters that would appear for minutes, then vanish without warning. The water around them started changing color. Clear blue shifted to murky green, then darkened completely as something stirred up sediment from the ocean floor. Then came the vibrations. Soft at first, like a distant engine rumbling beneath the boats. But it wasn't an engine. It was coming from the seabed itself. And that's when scientists realized this wasn't just bubbles. This was a warning. In the past week alone, more than 135 seismic events have been recorded beneath Naples. That's not normal background noise. That's the sound of something waking up. These tremors indicate the movement of superheated fluids beneath the surface, a classic sign that pressure is building in a magmatic system. The kind of pressure that doesn't just release gradually, the kind that explodes. Local authorities tried to downplay it at first. Seasonal gas release, they said, harmless biological activity, but when marine technicians dropped their instruments into the water, the readings told a very different story. Carbon dioxide levels had spiked far above anything they'd seen in years. Newly opened vents on the seafloor were pumping out sulfur-rich gases at increasing rates. Temperature probes detected something even more alarming. The ocean floor was getting warmer, not slowly over months, rapidly over days. These weren't surface disturbances. These were the earliest symptoms of something deep, something massive, and something rising. Beneath the bay lies one of the most dangerous volcanic systems on Earth, Campi Flegrei, a massive caldera that sits directly underneath one of the most densely populated regions in Europe. And right now, it's showing signs of life that scientists hoped they would never see again. There's a crack in the ground here, a fumarole, where superheated steam has been venting for centuries. But recently, the steam got hotter, the cracks got wider, and the entire region started doing something that made every volcanologist in Italy hold their breath. It started rising. GPS stations scattered across Naples began recording a pattern that sent chills through the scientific community. Rapid, synchronized ground uplift. For months, the land had been shifting upwards slowly. But suddenly, the breathing changed. The uplift accelerated. Entire neighborhoods shifted upward by measurable centimeters in just weeks. Sidewalks cracked open overnight. Pavements tilted toward the sea. Residents started noticing their doors wouldn't close properly anymore. Windows jammed in their frames. The land itself was warping beneath their feet. Civil engineers found subtle deformations spreading through building foundations. Drainage systems reversed direction as terrain tilted upward. Even the shoreline started creeping higher, exposing ancient Roman steps that had been underwater for generations. One researcher put it bluntly, living here is like living inside a volcano, because that's exactly what it is. But here's where it gets truly unsettling. The uplift wasn't random. Satellite data revealed a broad dome forming right beneath the most active part of the system. Something underground was expanding, gas, magma, or both, and it was pushing the entire region upward like a slow, powerful breath before a scream. If you're finding this as disturbing as I am, do me a favor and hit that like button. It genuinely helps me bring you more deep dives like this, and with everything happening in Naples right now, you're going to want to stay updated. And make sure you're subscribed because this situation is developing fast. As the ground continued rising, gas monitoring stations across the caldera lit up with readings that made scientists' blood run cold. Overnight, carbon dioxide concentrations shot far above baseline. Then came helium-3, a rare isotope that only rises when magma is moving upward through the crust. The levels spiked sharply. Then sulfur dioxide surged, a classic signature of superheated fluids, forcing through rock fractures. These gases weren't seeping out slowly. They were venting with force, rising through cracks beneath Pozzuoli, the Solfatara crater, and straight into the Bay of Naples. Thermal cameras captured glowing plumes of vapor rising from vents that had been dormant. Some released gas so concentrated that nearby vegetation turned yellow and died within hours. Researchers compared the chemical signatures to historical data. What they found made the room go silent. The mix matched conditions recorded right before the 1538 Monte Nuovo eruption. That event reshaped the entire region. And the current readings? They were even stronger. Emergency teams immediately installed portable monitors around schools, ports, and residential blocks. The worry wasn't just that levels were high, it was how fast they were accelerating. And beneath the bay, the ocean itself started reacting. Thermal drone flights over the Bay of Naples revealed something that escalated the situation instantly. Broad patches of the seafloor were warming rapidly. At first, infrared signatures showed a small cluster near Pozzuoli. Within days, the hot zone expanded into a sprawling network of glowing streaks beneath the waves. Underwater sensors confirmed temperatures had risen several degrees in just weeks. Far too fast to be normal. The ocean above these vents started shimmering like a pot on a stove. Microvents multiplied, releasing constant gas streams that made the sea look like it was simmering. Some stretches produced enough bubbles to physically push small fishing boats sideways. Marine biologists documented fish fleeing in massive schools. Divers reported visibility warping from rising thermal plumes, like looking through heat waves on a desert highway. These weren't isolated hotspots. The pattern pointed toward a massive body of pressurized heat moving beneath the crust, creeping upward, releasing energy through every crack it could find. If this heat front kept expanding, it could destabilize the entire seabed, a precursor to violent hydrothermal explosions with almost no warning. But even that wasn't the worst part. As gas emissions intensified and the seafloor continued heating, the ground responded with a deeply unsettling rhythm. Clusters of shallow earthquakes began striking Naples and surrounding towns, sometimes dozens within a single hour. These weren't deep tectonic quakes. These were occurring just a few hundred meters down, right where pressurized magma and superheated fluids forced rock to fracture. Residents reported windows rattling through the night. Shop owners found fresh cracks across their walls every morning. Seismologists reviewing the waveforms noticed something that made them uneasy. The quakes were becoming shallower, sharper, and migrating toward the area directly above the most active gas fields. This wasn't random shaking. This was the crust deforming under rising internal pressure. And here's what makes that absolutely terrifying. The last time Campi Flegrei produced this exact pattern, an eruption followed within days. Civil protection officials quietly raised monitoring levels and dispatched teams to inspect schools, bridges, and hospitals for structural stress. Every tremor sent the same message. The system below was tightening like a clenched fist, building pressure, looking for a way out. High-resolution radar and GPS data delivered the most alarming discovery yet. The deep magma chamber beneath Campi Flegrei was expanding, slowly at first, then with measurable acceleration. Instruments showed molten rock melting its way upward, softening the crust and creating new pathways for gas and heat to rise. This wasn't the stable chamber scientists had monitored for decades. Its internal pressure had fundamentally shifted, suggesting fresh magma injections from even deeper within the Earth. As this reservoir pushed upward, computer models indicated increasing stress on brittle rock layers already weakened through years of uplift and seismic activity. Geophysicists compared current readings to historical records and found disturbing similarities to the buildup before past explosive phases, including that 1538 eruption. But this time, the affected area was far larger. Pressure simulations warned the magma chamber was approaching a critical threshold where even minor shifts could trigger cascading failures throughout the crust. Researchers described it with one chilling phrase: a system entering a phase we hope never to see again. And then scientists started noticing something that made the hair on the back of their necks stand up. They began cross-referencing modern data with historical accounts from months before 1538, when Monte Nuovo, the new mountain, was born. What unsettled them wasn't a single anomaly. It was watching an entire sequence repeat itself with unnerving precision. Gas emissions were climbing along the same coastal arcs, where Renaissance fishermen once reported burning vapors rising from the sea. Shorelines were subtly shifting, matching documented patterns that preceded the 1538 eruption by mere weeks. Even the uplift rate showed a familiar rhythm. Slow pulses followed by abrupt accelerations, identical to measurements inferred from old structural damage records preserved in Italian archives. Each new data set strengthened the parallel, forcing researchers to consider a possibility they once viewed as distant. That Campi Flegrei may be entering a phase comparable to the one that produced Italy's most recent volcanic birth. The echoes of history weren't abstract. They were aligning in real time. As scientific reports circulated through government channels, Italy's Civil Protection Agency escalated its response without public announcements. Internal bulletins upgraded alert protocols. Sirens in coastal towns underwent unannounced tests, their sudden wails catching residents off guard. In schools, teachers quietly rehearsed emergency exit procedures, framing them as routine drills rather than crisis planning. Street-level notices started appearing, new assembly points, adjusted hazard zones, revised traffic flow maps for potential mass evacuation. The government wasn't saying much publicly, but its actions were speaking volumes. Something was changing beneath Naples, and margins for delay were shrinking fast. Beneath the bay lies a network of chambers and vents that behave very differently from land-based volcanic systems. Volcanologists warn that if pressure continues building, the first breakout might not come from a visible crater on land. It could erupt from under the water itself. A confined pulse of steam could flash into existence, driving an underwater blast capable of lifting a column of scalding water, ash, and shattered sediment straight into the air. Models show even a modest hydrothermal explosion could send waves slamming into the nearest shoreline within minutes, while raining superheated debris across ports, beaches, and neighborhoods. The danger isn't necessarily the scale, it's the speed and proximity. With fishing boats, ferries, and waterfront homes sitting directly above unstable ground, the impact window would be brutally short. Experts stress this scenario, while potentially smaller than a full magmatic eruption, remains one of the most immediate threats. Yet beneath every simulation lies a deeper concern scientists cannot ignore. Across every monitoring station, the alarms aren't tied to just one variable, they're tied to all of them moving together. Ground uplift continues in irregular surges. Gas levels spike beyond historical baselines. Seismic swarms ripple beneath multiple caldera sectors, and patches of seawater and crater pools are heating to temperatures indicating boiling activity just meters below the surface. Individually, none of these signs guarantee an imminent eruption, but combined, they form the exact convergence pattern researchers have long feared. A fragile crust suffering stress from multiple directions simultaneously, vulnerable to even slight changes in pressure or temperature. The real danger isn't some dramatic trigger. It's a subtle shift that pushes the entire system across its threshold without warning. For scientists tracking every tremor, every gas spike, every temperature change, the margin between stability and catastrophic escalation is narrowing with every passing day. These shifts don't go unnoticed by people living on the caldera. Locals who have spent their entire lives here can feel the tension rising beneath official calm. Conversations in cafes increasingly revolve around signs everyone's noticing, but nobody's openly discussing. More patrol cars near monitoring equipment, more helicopters scanning fumarole fields at odd hours, more late-night meetings in municipal buildings with no public explanations. The government isn't saying much, but its actions speak clearly to anyone paying attention. Something fundamental is changing, and every precautionary measure signals that time for delay is running out. So here's the question that now shadows the Bay of Naples with growing weight. Could the bubbling sea be signaling a disaster the world isn't ready for? Could we be watching warning signs of a volcanic event that will reshape not just the coastline, but our understanding of how quickly these systems can awaken? The data says we're closer than we've been in 500 years. And every day that distance shrinks. Let me know what you think is going to happen next in the comments below.